Hi everyone, here we are in the Van Veldhuizen kitchen, getting ready to do a little science. What'd you bring with you today?
I brought milky quartz.
Milky quartz. That's a type of rock, right?
Yes.
What else do you have there?
Crystal.
Where'd you get those?
Arkansas.
Yeah, Hot Springs, Arkansas. So, if you want to do a little social studies with this science experiment, we talk about how the hot springs, the hot water, and the minerals down in Arkansas create crystals. Check out that crystal. Really cool and clear. Really awesome. It's milky quartz. So today we're going to grow some crystals of our own. So these align with some of the 5th grade standards. You could use 5th grade standards for the physical science 1, 2, 3, or 4. Any of those are going to work for you guys. It talks about mixing substances, seeing how they heat and cool, showing how particles that are smaller can't be seen once they're like dissolved, and also mixing 2 or more substances to result in the new substance. So, what do we need for this lesson today? Petri dishes. So we bought a few off of Amazon. Borax. Table salt. We're trying 2 different kinds. Iodized, or sea salt, which is not iodized, and our regular Morton salt with iodized. We really don't know if there'll be a difference in our crystals, so we're going to experiment and see. Also, sugar. We got sugar over here. String. We just used some embroidery string from our sewing kit. Scissors to cut your string. Hot water. We made a nice pot full. A hand lens, which we'll use after our crystals are done to investigate and explore. A cup, so we can mix everything. Alum. If you haven't heard of alum, it's also called potash. You can find it in the seasoning aisles right there.
In the grocery store.
A spoon to stir stuff. Hey, did you bring your safety goggles? You're definitely going to need those. Also, we used a marker and tape. What we decided to do for our experiment was
label them.
We labeled all of our strings, so afterwards we'll be able to pull them up, compare them to our piece of paper, and know what we actually mixed together to create those crystals. Also, this works great if you're a teacher in a classroom, you want to make up crystals ahead of time and then have them ready for your students to compare after they've made like 1 or 2 crystals. Then they've got them there. You can let them compare by just checking the numbers, and then they can, guess and try to decide what were those crystals created from. So, easy way there. Also, we brought with some food dye. We thought maybe we could create different colors. So if you had it where you were having an engineering standard where you were trying to have the students work on a budget to budget out their supplies and see what they could buy to make stuff, you could put food dye as an item. Also, we have one last crazy thing we're going to experiment with today, and that is Pepsi. We decided, with the cool different color, high sugar content, we're going to boil it up and see if we can create crystals. Don't know if this is going to be a fail or not, but we're so glad that you guys are here to join us for this. So, starting off, some of your key terms are going to be evaporation. You're going to talk about how the water changes from a liquid to a gas. Because once we mix these up, we're going to dissolve all those things the sugar is going to dissolve into the hot water. But then when we leave it there over many days, evaporation is going to occur. And then what's going to form when evaporation occurs, do you think? What do you think might occur? If we mix the salt and the water, we leave it on there.
Crystals.
Yeah, crystals. That's what we're hoping for. So we need that evaporation, the liquid to go away. So crystals, they're going to be those little tiny atoms and molecules that are arranged in a microscopic structure. And crystals actually kind of have a little bit of a lattice form.
Goes up in evaporation.
Yeah. So you see snow crystals out there. You brought your rock crystals. You can kind of see those. Yeah. Obviously in the classroom, if I were you, I'd have hot water in a thermos, and I would have some styrofoam cups.
Be careful.
We're here in our kitchen today. We've got measuring cups here on our glass cups.
Mason jars.
This will dissipate pretty quickly, so we're going to get going here. what do you want to do with your cup to make your crystals first?
Oh.
What do you want to choose from? Go ahead, pick. You're going to do borax? Okay. I'm going to do the sea salt. All right.
Heavy stuff.
We're going to pour in as much as we can and start stirring until it gets dissolved.
You didn't open this for me.
Oh, sorry. My apologies. Now, for you people for your students that make slime, they may have borax around. You can find this in the laundry aisle. There you go. Borax is open, and we're in business. I'm going to grab an extra spoon and stir it up.
How much?
We want to be able to make sure we dissolve it. So stir until it's dissolved. And then if you need to add some more, add some more. Because that may help us form what?
Crystals!
And the more we get dissolved in there, the better chances we're going to have to grow more and more crystals. Okay? Once we get them all stirred up, we're going to put them in our Petri dishes.
We are?
Yeah.
What is it?
So you can check to see, hold it up, see if it's dissolved. I put a lot of salt in mine. I'm really going to stir it here. I may have put in too much. So that's something definitely experiment with. You can kind of know ahead of time if you need to.
More there.
So then our little Petri dish. We're going to lay down in our Petri dish. We're going to go ahead and pour in our solution. And it said, you know, you can put it on a place that's not going to get disturbed. So we're keeping ours on a big cookie sheet so we can check them and kind of move them from the table, but then not disturb them throughout the week. So here I go. I'm going to pour this in my dish. And then my salt is number 8. So I'm just going to stick the string in it, kind of submerge the string down in it. I don't know if... Yeah. There we go. And then we'll leave the string sitting out. So that number 8, I can write down on my piece of paper, is sea salt.
What?
What did you have for number 1?
I had borax.
Number 1, borax.
Should I pour some?
Take the lid off first.
Wait, oh my gosh.
All right, pour it in. Looking good, looking good. Keep going. All right. And then
Okay.
add your string in.
And this is number 1.
Oh, here you go. Yeah. So we're just going to put
Ooh,
that in there.
Warm.
Kind of let it sit.
Nice and
So,
warm.
we're going to go ahead, whip through some of our other ideas here on creating some stuff. For time and ease of stuff, we are going to just use a few extra different cups we bought here to make our crystals.
Oh, really? No.
We're going to experiment with the food color, the sugar, and the and then in a few days, we'll get back to you once you can see what our crystals look like.
And Pepsi.
And Pepsi. And in the meantime, if you don't have the time with your class to check, this is a great thing you can do over the course of a week. Let them check in on it. Start on a Monday, check it on the following Monday over the weekend. Or you can have kids snap pictures of it. Those kids love taking pictures. Let them take pictures day by day, and then you can do a little flip book to see how the crystals are slowly growing over time. Other modifications may be, I know they talked about putting them in the refrigerator or finding other ways to get the water to evaporate faster. But we'll check back in with you in a little bit here. Bye!
Bye.
What are you going to make? What one are you working on? Here's your water. All right, so we look like we're doing well. We're almost done.
Hey, Mom, should we put the lids back on?
Well, I don't know. Would that help? What would it do if we put the lid back on?
That would probably not help with evaporation.
Yeah, we're counting on evaporation to pull the liquid out to create the crystals. So let's just put the lids back in the bag. And we're on to cleanup. Hi everyone, we're back here in the Van Veldhuizen kitchen. I'm here with my son Nash. Say hi.
Hey.
And if at this point, after you've gotten your crystals all put together, you could have your students draw out predictions of what they think the crystals will look like. But our crystals are done. It's taken us a few days to let them dry. What'd you bring with you?
Magnifying glass.
Yeah, That's going to help you take a closer look at these crystals. Which crystals do you think are interesting here today?
Well, what I think is the most favorite, the best are the ones formed from Ulm.
What makes the ones formed from Ulm different from the other crystals?
Well, they always, both of the Ulms, they made these really interesting geometrical shapes.
What geometrical shape did they make?
Sort of a triangle-like shape, I'd say.
Triangular, yeah, a little bit of a triangular crystal. It's pretty awesome, the Ulm is. We did one with dye, and we used a refrigerator with one to also do it differently. Do you remember what this crystal is here made out of?
Yeah, it's sugar.
Sugar. So that's basically if you were to make like rock candy, crystals made out of sugar. This one I wasn't so happy with. I think you could do crystals a different way with this one, but this one was made out of, can you guess? Do you know?
Salt, maybe?
Good guess, not quite. This one was made out of borax, the laundry detergent.
I asked you.
We had two other ones made out of salt. And we'll just show you, hold them up here. You want to hold up that dish. There's like some salt crystals. And you can see they really stuck to the bottom of the Petri dish here. So we did some changes between using different colors. We did blue with the sugar. We did green with the Ulm that we stuck in the refrigerator. So after you've done all of this, you have some really cool crystals that you can investigate with. You got your thing? Go ahead and investigate. Check those out. Now, the two standards that I would apply to making crystals, I have a few in my document, but the ones that I like to highlight are 5PS1-1. So develop a model to describe that matter is made up of particles too small to be seen. And this can go ahead and go hand in hand with a language function of justifying with evidence. The kids can see that when we've added together Ulm and water, the Ulm dissolves and we essentially just have a liquid that's dissolved in there. But once it's dried, it's created something beautiful. What did it create?
Crystals.
Crystals. So we have evidence here that even though we dissolved those particles and they were too small, we still created something after it evaporated. We made those crystals. Also, another one would be 5PS1-4. Conduct an investigation to determine whether mixing of two or more substances result in a new substance. And we mixed a granular Ulm, which was really tiny, with some water, and again, we created crystals. So I hope you guys have as much fun making crystals as I did. We did have a loss here with the Pepsi. We found out Pepsi does not make crystals. It makes what?
A molasses-like substance.
Yes, something sticky and gooey. So, but it was an experiment and worth a risk we could take. And we learned something new, right?
Yep.
Pepsi does not grow crystals. So, I hope you have fun. Also, if you were to try growing crystals, you can also try growing them on pipe cleaners. Do your students have some more to investigate? You could do that at wintertime and make them into like snowflake shapes so they can go ahead and correlate crystals in nature with crystals created in the classroom. Thanks you guys for watching. Hope you have fun doing science.